everyone. Today we're going to be we're still solving quadratics, but we're going to be staring at them just a little bit differently. Today will require very little, actually no factoring. So that's a nice break, and something we haven't done in a while. You will notice that things are not linked in this unit the way that they normally are, and that's because things in this unit don't build off of each other quite as much. You can't scaffold them quite as much, where here's what you need to know, here's the next step, here's the next step. It's kind of three different ways of solving quadratics. So this is not going to be linked the way that other things are. So if you snuck in here and think you're going to something, you're not. You're doing this intentionally. What I want to look at today is something like x squared equals 25. And what that means is some value of x, if I square it, will equal 25. Okay? Some of you are already thinking, oh, so 5. 5 times 5 is 25. Remember, square means it's something multiplied by itself. And you're right. 5 is an answer. There are two answers to this problem. And let me demonstrate. In order to solve this, we're going to need to take the square root of both sides. Okay? So, we're going to take the square root of both sides, which you're allowed to do, because as long as we do it to one side, you can do it to the other side. And then we'll get x equals, and here's the tricky part. Because we took a square root, there's also the possibility that this answer is a negative 5. So the answer is x equals plus or minus 5. So you'll have two blanks, and the options will be 5 or negative 5. Okay? So that's what we're looking at right here. Take the square roots of both sides. But it's very important that you only take the square root of an x squared. Let me demonstrate. If you have, let me look at these problems real quick. So let me show some good ones for you here. That one. Terrible. X squared minus 55 equals 26. 26. Okay. Couple of things. Number one, notice 26 isn't the perfect square, which should make you a little suspicious that maybe I'm not quite ready to do this yet. Although you can plug these things into your calculator and get a decimal. That's fine. I'm going to try not to shoot for that today. So be suspicious of these problems. Okay? The other thing you should notice is that if I try to take the square root of the whole left side, it's not just an x squared. I've also got a minus 55. Now I know how to deal with the square root of x squared. That's x. Square root of something squared is just itself. Okay? But if it's the square root of this whole side, and that's what you do, it's not the square root of x squared and then the square root of 55. It's the square root of the whole side. I don't know how to do x squared minus 55. So we're not going to. We need to get this x squared by itself, which is exactly how we do a whole bunch of other problems. Whenever you're solving for x, the first step is get your x's by themselves. So let's add 55, because that'll cancel that out. But you have to do it to both sides. If two things are the same, and you do the same thing to both of them, they will still be the same. Okay? So we're adding 55 to both sides. Everything will cancel on this left right here. Because if I subtract 55 and then add 55, I'm backwards. Right? So I've got an x squared equals 26 plus 55 is 81. And 81 is a perfect square. You'd be thinking like that. That looks like it's going to work out pretty well. Maybe something's going on here. X is finally by itself, other than that square, so we're going to get rid of x squared. X will equal plus or minus. That's that plus or minus symbol. It's kind of a plus sign over a minus sign. The square root of 81, which is 9. It may behoove you to know some of your perfect squares. Let me give you a list of them, and then we're probably going to call it there. no, there is one more thing I want to talk about. So before I give you the list of perfect squares, there is one more thing that I want to talk about. Let's say you have an x squared plus 5 equals 0. Okay. We know already that looking at this problem, we got to get x squared by itself. So, in order to get rid of a plus 5, we can subtract 5. We're going to do that from both sides because we're not going to cheat math. Not that that's cheating. More of breaking the math rules. But I guess it's kind of cheating. It's a form of cheating. Cheating it. It's illegal, don't do it. Alright, so we're going to be left with an x squared equals a negative 5. And the next thing that we need to do is take the square root of both sides. Now, some of you are thinking, whoa, that's a 5. I know what the square root of 5 is. And that's good instinct. Okay? If things look really different and gross in a math class, there's a pretty good chance that maybe we did something wrong. Okay? But that's actually not the problem with this. The issue here actually is the square root of negative 5. If I take the square root, if I square something, if I multiply anything by itself, I always get a positive. 2 times 2 is 4. Negative 2 times negative 2 is positive 4. 8 times 8 is 64. Negative 8 times negative 8 is 64. Because you have to multiply it by itself. A positive times a positive is a positive. A negative times a negative is a negative. So because it's the same number twice, you always get a positive. So x squared equaling the square root of negative 5, well, there isn't a square root of negative 5. At least, there's not a real number. Okay? Eventually, and I don't think we touched this here. Let me go check real quick. Using computing with the squares. I don't think, yeah, we're not going to touch. We're not going to touch imaginary numbers. Even though I think they're kind of fun. But we're not going to touch them. So, we are going to say no real solutions. Because I can't do it. I can't take the square root of a negative number without getting something imaginary. In the assignment, you just write NRS, no spaces. If you add spaces, it'll be wrong. Okay? So either type no real solutions or write NRS for no real solutions. Okay? And it is important that you say no real solutions because, like I said, there are imaginary ones. So if you say no solutions, that's technically not true. And imaginary things, like dragons, you take offense to that. And you don't want to offend a dragon, just in life. That's just solid advice. Alright. Real quick, I do want to give you just a list of a bunch of squares, just so that you recognize them, and it would be a good thing to have in your notebook. So this, for one of the notes, you should be probably writing these problems down. And it would also be a really good idea to write this next bit down, pause it when I'm done writing, and then we'll have a list of perfect squares. I have a blue marker. I don't know where that came from. We're going to find out if it's any good or not. 1 squared equals 1. 2 squared equals 4. 3 squared is 9. You can skip until I'm done writing. I won't take offense to that. 5 squared is 25. Or maybe you just really like the sound of my voice. That's fine. That's totally understandable. 7 squared, 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. And that's actually as far as I know how to go. That's not true. 15 squared is 225. But I don't know 14. Someplace between 169 and 225. Okay? So those numbers that might be a good idea to write down. I recognize you can't see them. Super great, so sorry. But you also just like look at the list of perfect squares online too. So this is what we're shooting for today. Tomorrow we're going to build off that. We'll maybe look at some cube roots, things like that. we're going to have to do some completing of the square, but this is what we're staring at today. So if you've got questions, ask them, either go to Google Meet or ask them in class, and I will see you